Okay, question 10. Straight line graph question. We will look at straight line graphs again at the beginning of year 11. I know you haven't done them since year 9, so this one could have been quite hard. Sorry about that. My defence, I didn't write the paper. But, you know, you should have done enough in year 9 and hopefully have some idea. So if we want to find the intersect of two straight line graphs, I need to use simultaneous equations to work out where they cross. Okay, so I need to work out the equation of each line. I haven't got that yet. L1 goes through 4, 6 and 12, 2. So if I draw a quick picture, it's 4, 6 is about there, 12, 2 is there. It's going to look something like that. It's got a negative gradient. It's going down as we go from left to right. Okay, it's going to have an intercept somewhere up here. Okay, so to work out the equation of L1, we have to work out the gradient. The gradient is m. And to work out the gradient, we do change in y divided by change in x. Change in y is 12 take away 6. Sorry, 2 take away 6. And the change in x is 12 take away 4. Okay, so 2 take away 6 is minus 4, 12 take away 4 is 8. So the gradient is minus a half. The equation of a straight line is y equals mx plus c. I know m is minus a half x plus c. I need to work out what c is. To do that, I can sub either of the 2 points I've got of a line in as y and x. So this is x and this is y. So when y is 6, we get minus a half times x, which is 4, plus c. Minus a half times 4 is minus 2. So 6 equals minus 2 plus c. Add the minus 2 and we get c equals 8. So the equation of that line L1 is y equals minus a half x plus 8. And that makes sense from our picture. Okay, it's got a negative gradient but not too steep, and it goes through a point somewhere up here. We bear in mind that's got a point 6, that's got a point 2, so 8 probably makes sense. Okay, equation of L2, I'm just going to get rid of all this now. It's got a gradient of minus 3, so we know the gradient. So we know it's going to be y equals minus 3x plus c. Now c is a y-intercept, and we're told it goes through the origin. So it's going to look something like that. So we know the y-intercept is 0, which means c is 0. If you didn't think of that on the spur of a moment, you could say, well, we know it goes through 0, 0. So 0 equals minus 3 times 0 plus c. When I put in y equals 0, x equals 0. So we get 0 equals 0 plus c, so c must be 0. Okay, so when I replace c with 0, minus 3x plus 0, and even bother writing it, I get the equation of L2 is y equals minus 3x. Okay, now comes the next tricky bit, working out where they intersect. Well, they intersect where y is equal to that and y equals to that at the same time. So y equals minus a half x plus 8, and y also equals minus 3x. So at the same point, they've got the same x coordinates and the same y coordinates. So it's simultaneous equations. The easiest way of solving this is to say, well, if y equals that and y equals that, then that must equal that. So I can say minus a half x plus 8 equals minus 3x. Okay. Easiest thing to do is probably add the half x. 8 equals minus 3 plus a half is minus 2.5. So 8 is minus 2.5x. And then you've got a calculator, you might as well just divide by minus 2.5. So x equals 8 divided by 2.5 minus, and we get x equals minus 3.2. Okay. Once we know x, we can work out y. Y is equal to minus 3 times x. So y equals minus 3 times 3.2, which is 9.6. So we get the coordinates of P, minus 3.2, 9.6. Okay, not an easy question. Well done if you got anything on that.